And here's our frame network one more time. If you want to jot these delcies down, I think that is a fantastic idea. We're using the 172.12.123.0/24 network, and the router number is always the last octet, and we're using delcies 122 and 123 on router 1, 221 on router 2, and 321 on router 3. The reason that we only need one Delcy right now on our spokes is because they are spokes. We're going to use the same Delcy on router 2 to send data to routers 1 and 3 because what's the next hop? It's always going to be the hub. It's always going to be router 1. Same goes for router 3. There is an intermediate hop, so we're going to use the same Delcy 321 to send data to router 1 and also to router 2, which has to be, of course, via router 1. That's why you see your hub router with multiple Delcies, but your spokes may only have one. And that's what we've got. So let's go ahead and dive right in. Let me straighten that up a little bit. And we will start over on router 1. We're going to look at the syntax of this command. We're going to nail that down, a couple of show commands, a couple of verifications, and we will move on from there. Let's make sure I'm on interface serial 0. First two things I did, encap frame, and then I disabled frame relay inverse ARP. And now we're going to start with the frame map command. Let's take a look at the syntax of this. First, you got to name your protocol. Here we're using IP, so that's what I'm going to go with. Protocol specific address. Notice that iOS help is not incredibly helpful here in telling you what address. You know, is it the local address? Is it the remote address? That's why I was hitting you so hard with that earlier, because you got to know that. And it is going to be the remote IP address that we are mapping to. And we'll do router 2 first. You'll also notice for Delcy that it doesn't exactly say local Delcy or remote Delcy or anything. You got to know. So again, we're using the local Delcy, which in this case is 122. And those are given to you, by the way, by the frame provider. In the real world, we're not just making up Delcies. They have to give them to us. So we're at 122, and we've got a bunch of options here. Broadcast, Cisco encapsulation, don't compress the headers. This is all stuff we'll work with in future studies. So let's see. We've got a CR at the bottom of that list, and that means it is a legal command. So let's just use our up arrow to repeat that one, and I'll do 3 and then 123. And then let's see if that interface is open. It is now. And let's check our show frame map. We haven't done that one yet. And you're going to see here when you run this, it's going to give you the interface. It's going to give you the status of the interface, the IP address you're mapping to, your local Delcy. Static means that we wrote it. Of course, dynamic means that inverse ARP wrote it. Cisco is our encapsulation. It's going to be either Cisco or IETF, and Cisco is the encapsulation. That's what we're sticking with. And status defined, okay, and inactive. Okay, so it looks like our line protocol is staying up, but why do we see inactive here? We see inactive here because we haven't gone to the other routers and configured them yet. So while it's fine to run show frame map now, you really can't do too much verifying or too much troubleshooting until you get all 3 routers done, or however many you have. So let's head over to router 2. No frame inverse. We'll do a frame map. Let's look at that syntax again. Got to have this down. Protocol, then remote address, and then local Delcy, which in this case was 221, and we're done. And we're going to do a mapping to 3 with 221 as well. Perfectly fine. And no shut. Let's watch that come up. We're waiting for the rest of it to come up. Show interface serial 0, line protocol is up, and it's there it goes. Okay, just took a second. Now we've got also a message here, FIR 5 Delcy change, so we can assume that FIR is for frame relay. Interface serial 0, Delcy 221 state changed to active. Active is almost always good. We've got one instance in this entire course that active is not good, but this is not that instance. So everything is looking good right now. And we've got a couple of actives here, which is great because now routers 1 and 2 have been configured, so we could expect that to go active if everything was configured correctly, which it was. And let's go to interface serial 0. Let's try in-cap frame instead. 123.1, and we're using Delcy 321 here, and again, that's a legal command. Same Delcy, we'll do a no shut. Change state to up, and let's do a show frame map here and see what we can see. We see inactive, but let's give that a few seconds because we saw the line protocol just came up. And there we go, we went active. So you can see active right here is really what we're looking for. We saw inactive earlier, but you do have to give that a few seconds to cook, so to speak, as I call it, because it's not going to happen immediately. So everything looks good so far. Let's go out to show us R1 and run a show frame map. And everything looks good. The ones that were inactive, of course, now have gone to the other routers. We've opened them up. Everything is beautiful there. So let's test our connectivity. Let's see what's going on there. We should be able to send pings around at this point. Looks good so far. I like all those exclamation points. Looks pretty darn good. So right now our frame map is fine. Let's run show frame LMI. That's a good one for this point. And you can see that we've got 7 sent, 8 received. So as long as they're very close to each other, we're gold there. And we use the default of Cisco on that anyway. So really it's just that simple with frame map statements. Almost. Because let's go back and take a look at one thing here. Let's do a frame map statement. And let's look at our options here. Now, I mentioned that this is an NBMA network, and broadcasts were not forwarded around the network by default. And you can see the very first option here we have is broadcast. Broadcast should be forwarded to this address. Now, a couple of things. First, putting broadcast on the end of a frame map statement is so common that a lot of people think it's required, or it's part of the command. It's not, as you can see. It is strictly an option because we use frame map statements without the broadcast option, no problem at all. So why are we able to send pings around right now? And what's the big deal, right? Well, we were able to send pings around because pings aren't broadcasts. Pings are unicast. They're unicast to the address to which we specify. So the pings are flying right around, but what we're going to do next, we're actually skipping ahead a little bit because I know you can handle it. What I'm going to do, we're going to configure OSPF on this network now. If you haven't even looked at OSPF, if you don't even know what OSPF stands for, it doesn't matter. Because the concept I'm going to show you, you will grasp immediately, and then I will mention it again in the OSPF section. But there's a little method to my madness. Hang in there. And on the very next video, I'll already have OSPF configured. We will configure it live in the OSPF section because I want you to see a little something now. So hang in there, and I'll see you on the next video.